If you've read the video description or even the title, you've probably already figured out what this video is about. So before we get started, I'm just going to apologize in advance for the sometimes poor audio and video quality and occasionally the lack of pictures, because when you're working you really don't remember to stop to take pictures. The way this project got started was because I had a guided independent study in the electronics room at my school. So the teacher asked me what I was going to build. So I spent a few days looking up circuits, thinking about what I was going to do, and I decided to build a power supply. Now my reasoning should be pretty obvious once you see these pictures. I already knew about this specific circuit before. It wasn't the simplest circuit to build or the cheapest. I think this project cost me about $100 and a couple months. The thing about taking on a fairly complex project is that it'll get me a better mark. To be honest, we just kind of winged it. After I started the project, some of my friends joined in, so 4 of us built the same power supply more or less, and that helped save on some costs. I designed as I went, as I figured out how big everything was, what it had to connect to, where it had to go. So there were a few prototypes I built before finalizing the design. I did produce both a 3D model and a bunch of drawings. The 3D model I had to do to get marks for this project. The drawings I needed to actually cut things out. We already had a board layout and a pretty much complete parts list. We did have to design and build some ancillary boards for connectors, secondary power for the meters, that sort of thing. Once we figured out what we were doing, we ordered up the parts, and where we got them is linked in the description.
These are like $4 each.
Yeah.
We ordered a lot of extra of these because Steve will blow them up.
Yeah.
Much smaller than Steve because Steve needs a lot of extra parts and random junk that won't actually work. These are switches. Chris convinced me to order them because they do look kind of cool. And these are op-amps. There's 25 of them because I know we're going to blow one up. Anti-static bags that I'm going to have to keep because I like anti-static bags. 3 amp diodes at 200 volts. What is that?
Before we even had all the parts, we started to put together the circuit boards. The process is pretty much the same for each one of them. The main circuit board was already laid out and created, but all the other ones we had to make ourselves. We used a program called DIPTRACE. It's what we use at school. Personally, I prefer it over Eagle. Sorry, Eagle fans. We print the pattern out on a piece of special paper. The toner is then transferred using heat press to the piece of copper. We remove the paper, put it in the etching tank, which actually sprays heated etchant over the boards. After the board is etched, we scrub off the toner and drill the holes. When that's done, the board is ready for component placement and soldering. Basically, as soon as I had the majority of the components, I started laying them out to figure out roughly what would go where. I grabbed a piece of plywood, screwed all the parts to it, and jokingly but affectionately called it a breadboard prototype. Having that prototype allowed me to get the wires about the right length, so I wired everything up on that prototype and actually had it running. Once the core circuitry was finished, the next task was to build the front panel. I'll get to how I actually built the front panel in the next section, but after I finished it, I screwed it to the front of the final base plate, which is simply a piece of 3/4 inch plywood, screwed the back panel to the same base plate, called this prototype open frame, and I tested this one too.
Started at 5 volts.
Okay,
sure, why
this
not?
is load testing. Turn up to 12. At 12 volts, we're pulling just under 2 amps. Give it about 15
It should be pulling a lot more than that.
until the current limit trips. Turn the current limit now.
Wow, this is a bunch of
Current limit tripping at just over 3 amps. Turn it down before it blows up. Now a quick word on size. I laid everything out, measured it, sketched a crude drawing on a piece of paper, and determined the minimum dimensions to be roughly 8 by 10 by 5, which is what I ended up with. I did make a 3D model in PTC Creo, which is but to be honest, for the actual building of the thing, I referenced that crude sketch you just saw much more than the actual 3D model. I decided to go with a plywood base plate because it's cheap, easy to work with, and rigid. I used ABS plastic for the front and back panels, as well as the top piece, which is a U shape that goes over top, has slots for the front and back panels, and screws straight into the plywood base plate. I used Adobe Illustrator to design the panels. Illustrator is better than CorelDRAW, but it's simply not up to the standards of other Adobe products. At school, we have a laser engraver, which can also cut through certain types of plastic, ABS included. So the front and back panels, as well as the top, are all cut out on the laser engraver. No manual cutting necessary, which is good because I suck at that. I did have to bend the top, which is kind of an interesting operation. Squares to hopefully keep it square. After that, it was basically a matter of screw everything together and turn it on, and that's where things got interesting. The power supply project had its share of minor problems, from discovering that the ammeter needed an independent power supply, to forgetting to connect the grounds, thus causing the voltmeters to go crazy. I found out that the original circuit has some serious issues. So I consulted a revised schematic and parts list, ordered some new parts, threw them in, crossed my fingers that it would work, and it did. Except for that time I overheated and blew up that power transistor, but moving on. Okay, so I finally finished, and it won't blow up this time, hopefully. So let's run through a basic functional test and demonstration. So we got voltage. The meters aren't entirely accurate; they're cheap junk from China. So get your head out of the video.
It's not in the video. Ben's hand is, though.
That wasn't. You missed. Can you blow up the multimeter?
And as you can see, current limiting works.
I have a question.
Let's demonstrate the fine voltage control. So we got a nice LED. Let's keep going. Okay, now I'm out of fine voltage control. Now it's orange.
You're gonna blow up the LED.
Now it's red.
And now it's dead.
You just blew up the LED.
So is that for a computer part?
Yes.
Now it's gonna smell bad.
It passed the LED test. Let's see if it can pass the resistor test.
Now it's gonna smell even worse.
Where's the... Then do something pretty at the end.
Now it's gonna smell really
That
bad.
smells terrible.
No crap, Chris.